Now we go on to using matrices to solve simultaneous equations. Alright, an example. Let's work with this example one. Use matrices to solve the simultaneous equation. The simultaneous equations. It should be equations. Use matrices to solve the simultaneous equations. 2x plus y equal to 3. X plus 2y equal to 9. Right, necessary steps. Step 1. Express the simultaneous equations. Express the simultaneous equations as a single matrix equation by taking the coefficients of the unknowns to form a 2 by 2 matrix like this. We are saying we have taken the coefficients of x and y. Right, the coefficient of x here is 2, so we have 2 here. The coefficient of y here, when we say plus y, is the same as 1y, so it's 1. The coefficient of x here is 1, so we have 1. The coefficient of y here is 2, so we have 2. So if we take the coefficients of the unknowns here, we come up with a 2 by 2 matrix like this. And we rotate xy so that it becomes a column matrix xy. Right, now we are saying multiplying this will give us that. Right, it can go back to this. If you multiply first row by the column, you will get 2 times x, 2x plus 1 times y plus y equal to what? 3. And second row by the column, you will get 1 times x, it's x, plus 2 times y plus 2y equal to what? 9. Now, we've just expressed the simultaneous equations as a single matrix equation like this. That's the first step. Then step number 2. Pre-multiply both sides of the matrix equation by the inverse of the 2 by 2 matrix formed. By the inverse of the 2 by 2 matrix formed. Right. Now we find the inverse of this matrix. We all know how to find the inverse. We know that first we find the determinant. That's 2 times 2, which is 4, minus 1 times 1, minus 1. So we get 3. Inverse is equal to 1 over the determinant, which is 3, times the matrix interchange. What interchanges take place? These 2 and the 2 exchange positions, while the ones change their signs. Right, so we get this times the matrix is equal to, we multiply both sides of the matrix equation by the inverse of the 2 by 2 matrix formed. Sorry, here we have what? Our matrix. So we are saying times xy equal to, we multiply the inverse to both sides of the matrices. This is equal to 1 over 3 times 2 minus 1, minus 1, 2, this is the inverse of that matrix, times 3, 9. Right. NB, multiplying a matrix by its inverse gives the identity matrix 1, 0, 0, 1. So, if you know that you have no reason to multiply, you just know that these, you have no reason to do the real multiplication. You know that this one times this will give the identity matrix because this one is the inverse of that. Right, so you are left with the identity matrix, but it may be very good for you to do the multiplication, because if you have found a wrong inverse, it will mean you are adding disaster on top of a disaster. So we are saying do the real multiplication so that you find it for yourself that you get the identity matrix. But if you are sure, no problem. So we are saying this one will give us the identity matrix 1, 0, 0, 1. But on this side you have to multiply, because this one is not the inverse of that. So they will not give you 1, 0, 0, 1. You have to do the real multiplication. That's first row by the column will give minus 3 because it's 2 times 3, 6, minus 1 times 9, minus 9. 6 minus 9 is minus 3. And second row times the column, you get minus 1 times 3 is minus 3, plus 2 times 9 plus 18. What is minus 3 plus 18? It's 15. Now with the identity matrix, we have learned that multiplying the identity matrix is equivalent to 1 in value, and hence multiplying any matrix by the identity matrix 1001 does not change the matrix. So if we multiply this identity matrix by xy, it will remain xy, and we will say 1 over 3 times minus 3, 15. What do we get? We get our xy equal to minus 1, 5. So solution xy, x equal to minus 1, y equal to 5.